igneous rock, and it's granite. I want you to go ahead and try to find the granite. I'm going to give the kids at home a little update on what's happening here. Granite. You might have heard of granite because you might have it at home on a countertop or seen one at home. Will you get me 2 pieces of paper out of that little thing over there that are white? Okay, so we've already taken the notes. I kind of forgot to push record. It's okay. We're going to go over this super fast. First thing we talked about was that geologists are the scientists that study rocks. That's going to be important, so you go ahead and write that down. Next, we're talking about igneous rocks. They form when lava or magma cools and solidifies. That is just the definition of it. They're fast cooling, so they have small crystals, and Sophie told us that they cool fast. They have them small crystals because they don't have enough time for the crystals to form. So we said fast cooling, small crystals, it's lava, and lava is extrusive. That means that they exit the earth. And then magma, go ahead and write magma, just like you did lava on your papers earlier, not necessarily how we have it up here. Magma is going to be the opposite of lava. So where does magma cool? Evelyn, what do you think? Intrusive, so it's going to cool inside the earth. Those INs give it away. So magma equals intrusive, and then I want you to write inside the earth, just like we did on your papers for the lava. Just like it'll be the opposite all the way around from lava. So it's going to cool slowly. Why do you think it's going to cool slowly? The magma. Jaden?
Because it's hot inside.
Okay, it's hotter inside the earth. The lava cools fast because it's out here where it's cold. Magma is going to cool slow because it's deep inside the earth that holds the heat. So it's going to stay hotter longer. Takes it a lot longer to cool off. Why would it have larger crystals though? Why are we going to get larger crystals when magma cools? Jacaden? Takes longer to cool off, and there's a lot more time for those crystals to form, right? Okay. Did anybody think they found the granite on their tray? That's it. That's it right there. Did you guys find it? Did y'all find it? What do you think? Yeah. So I want you to look at that granite and tell me, kind of turn it in the light and see, that's it right there. What do you think? Did y'all find it back there? Yep. Turn it in the light and see what you can tell me about those crystals compared to that obsidian. So there's no crystals in the obsidians because it cooled so fast it didn't have time to make any crystals. What about the granite? What do you see when you turn it in the light? Zachary?
I see the light reflecting.
Okay, what's it reflecting off of?
The crystals.
It's reflecting off the crystals. So do you think that granite was intrusive or extrusive? He said intrusive because we can clearly see those crystals. They had a lot of time to form, so it must have cooled it inside the ground, right? I think that's amazing that we can look at that rock right there and know, just by looking at the crystals, where it cooled now that we have the information, right? I think that's kind of cool. All right, the next rock we're going to look at, you can go ahead and put them back in the tray. The next rock we're going to talk about is the sedimentary rock. This sedimentary rock, who has the definition for me in their binder from yesterday? Elias, go ahead and read that for us.
Forms when other rocks are deposited in layers, then compacted and cemented together.
Okay. Thank you, sir. So for the sedimentary rock, we're just going to write down that exact definition that Elias just told you. You got it in front of you on your notes. It forms when sediments are deposited in layers and then compacted and cemented together. They're compacted and cemented by gravity. They're not inside the earth. Sedimentary rocks form on Earth's surface, out here with us. So there's nothing really pushing on them or, squishing them. It's just gravity kind of holding them there. Does that make sense? Okay. Once you get that done, go ahead and put your pencils down so I know that you're ready to move on. I want you to look in your tray and see if you can find your sedimentary rock. One of them. You've got one that has a bunch of little pebbles stuck together. That's really the one that I want you to look at right now. The sedimentary rock with all the pebbles all stuck together. I just want you guys to look at it while we're going. You guys have it? Good. Good. So it's gonna be this one right here. That's it. Good. Okay, so whenever you look at that rock, what do you see? What can you see when you look at it? Zachary?
It's non-metallic.
Okay, it's non-metallic, but what can you see inside there? What's all stuck together?
Pebbles.
Okay, so Zachary sees pebbles in his. Do you guys see anything different in yours?
No.
Just kind of little pebbles, little bitty pieces of rock. Okay, so next we're going to write down all the different things that we might see in a sedimentary rock. You can often see sand. You've got your sandstone on your tray, right? That's a sedimentary rock. You see pebbles, just like you see in your rock, stones, or even fossils. So do you all remember that one from the video that had the seashell in it? That's kind of cool. You have all kinds of cool stuff in a sedimentary rock. Yes, ma'am.
I have a whole bunch of rocks like that. There's like little anemones in there.
Oh, that's awesome. Man, I love rocks. Hey, if y'all have a cool rock at home and you want to bring it up and show us, that'd be super cool. I mean, don't be bringing no Mongo rock, you know what I mean? But like, you can put it in your pocket or something. I love to see rock.
Well, when I was younger, there was this weird rock that had writings on it.
Oh, interesting. Okay, so our examples that we have here of sedimentary rock that we're gonna write down, the one that you have in your tray that's kind of that pink color, feels like sand from the beach. That's sandstone, so we're gonna write that down. We'll write down sandstone. If you wanna pick it up and feel it, you can. The next rock we're gonna write down is a conglomerate, and that's the one that you pulled out first that has all those little bitty pebbles and stuff in it that's all stuck together. And the last one is limestone. I don't have a piece of limestone for you to look at right now, but I'll try to get one out in the next couple of days so you can see what it looks like. And that's it for sedimentary rocks. Once you're finished writing those down, go ahead and put your pencil down because I'm going to move on, but I don't want to move on without you. Okay, while the last couple folks are writing down the rest of the information on sedimentary rocks, I need one of you to find a metamorphic rock in your vocab list. Who wants to tell us about a metamorphic rock? Go ahead, Ashlyn.
Existing rock is changed into a new rock by heat and pressure deep beneath earth.
Perfect, thank you, ma'am. So, metamorphic rocks, I'm gonna put down here, form when existing rock is changed into new rock by heat and pressure. So up here I underline heat and pressure, and I'd like you to underline that too, and we can go back over here to sedimentary rock and underline compacted and cemented together. While you're writing that down, I want to talk about the lines in the pictures up there. Okay, you see my two rocks right here? See the lines in this one and the lines on this one? This is a sedimentary rock. You see how they're straight across like that? See how this one's kind of messy in that picture up there? Keep that in mind. You see the difference in my two rocks right here? This is a sedimentary rock. Those are all straight across from each other. And then that rock we pulled out yesterday with the foliated lines, they're kind of messy. We'll talk about that in just a second. See my two rocks right here? How this one's all straight across from each other? See that kind of- And this one's kind of messy, like your picture on the paper. And then we'll talk about that just a second. You see them, Sophie? How they're different might see it better right there. See how it's kind of just messy? Okay. See the difference in the two? We got a sedimentary rock here, and that's straight across. This one here is kind of messy. See how it's kind of just got a... Okay. You show the hand. That's awesome. Love that. Okay, so I just walked around and showed the other kids these two rocks right here. So this one is a sedimentary rock, and you see how the lines are straight across on it right here? This rock right here is a metamorphic rock, and I don't know if you can tell, it's kind of just kind of loopy. You see the difference in these two? So they both have lines on them, but this sedimentary rock, they're going to be straight across pretty well every time, because gravity's about the same everywhere on Earth. You know what I mean? And gravity's what squishes that sedimentary rock. Well, this one right here, this metamorphic rock, is going to be deep in the earth. And it's moving because of heat and pressure. And you know how our tectonic plates, you know, they're always moving around? They might get folded over. They might get pushed up. They might get like whoopy, kind of like this. And depending on the rock, you can see it pretty clearly on a metamorphic rock. But I didn't want these lines to confuse you, so I thought I'd touch it. Just touch on that. Okay? I think we're all ready to move on. Speaking of those lines, I'd like you to write that they may have foliation. That's one of our vocab words. It's not on your list, but it's one that we talked about yesterday. Foliation is just these lines on it, not to be confused with these ones on the sedimentary rock. They may have foliation or ribbon-like banding. On your tray, you have the one that we talked about yesterday with those bands on it. It's called gneiss, but it's spelled really funny, G-E-N-I-S-S. Go ahead and pick that one up and you can look at it. So this is my example of gneiss right here. I don't know if you can see it really clearly. I'm sure you can see that, how it kind of has the different colors and they kind of loop around a little bit. Another example of metamorphic rock is marble, and you all have marble on your tray too, I believe. It's just a big old chunk of just gray. It's just gray. It doesn't have any speckles in it. It's just a gray rock. You guys can pull that out and look at it too. And then the other one that I have written down is quartzite, and that is another metamorphic rock. Here's my marble right here. It's just kind of a gray color. You might have heard of marble. Where have you heard of marble being? We use it quite a lot as humans. Where might we put a chunk of marble?
Countertop.
Huh?
Countertop.
Countertops. Yep. So if you've got a rock, a hard countertop, probably it's either going to be granite or it's going to be marble. And the difference between the two is how they're formed. Hey, when you're ready, go ahead and flip this paper over. We don't have very much time left, though. We got about 4 minutes. I don't think that's going to be enough, guys. We're going to start on it, though, okay? Okay, so this tells you how things can work through the rock cycle, okay? We're going to start from the top and go down on this side first. You with me? So we start from sediment, and something has to happen to sediment for it to turn into a sedimentary rock. And that thing that has to happen is compaction and cementation. So we end up with sediments. You know, we talked yesterday about the different ways that rocks and dirt and all that can be eroded or weathered or, you know, deposition and all that. That causes sediments, and they get compacted and cemented together, and we end up with a sedimentary rock. Okay, you guys can pack up, but can you do so quietly, because I'm gonna talk about this with kids, so I can get this video to them, is that okay? Okay, so now we're gonna go down over here. How can a sedimentary rock turn back into sediment? By weathering and erosion. So we wrote weathering and erosion right here. Sedimentary rock can turn into metamorphic rock by heat and pressure, and it's important to realize that there's no melting with that heat and pressure. It just gets hot enough to get kind of squishy, almost like hot plastic, and it can bend and fold. The pressure from the earth squishes it down. Sedimentary rock can turn into lava or magma by going one step further and being heated and melted. So now we talked about this whole half of our rock cycle map. Let's talk about the middle. We're going to start in the middle because you need to go in the directions that the arrows are pointing, and they've got one going up and one going down. Metamorphic rock can turn into sediment by weathering and erosion. It can turn into magma and lava by being heated and melted. And that's the middle. So now we'll look over at this side. We've got igneous rocks can turn into sediment the same way metamorphic and sedimentary rock can, by weathering and erosion. Igneous rock can turn into metamorphic rock by heat and pressure. It's not going to be melted. Igneous rock can turn into lava and magma by being heated and melted. And then once you get lava and magma, that can turn into an igneous rock by cooling and solidifying. Now you guys can see this exact paper under the Files tab in Unit 9, and that's the rock cycle notes. I want you to go in there and find it. Whenever you look at the questions below, you can just look at the map and just follow the arrows, and it'll tell you what goes with.